Welcome to video 8 in the Build Your Own AI series. In this video we're going to pause to fix a few things and then re-architect for our machine learning based chatbot. In the last video we set up Snowboy as our hot word detector. When the hot word is detected, our AI records 10 seconds of voice, but we want the system to stop recording as soon as we stop talking. To do that, we need to know what normal background sound levels are. Then, when sound levels return to that level, we can assume speech has stopped. Hot word engines run in a constant loop listening for the hot word. We can use the data they collect to monitor and average the background sound levels. Here in our Snowboy code, I've added in the Audioop library, which has functions to gauge sound levels, and my own function to constantly average the sound levels over time. Then, when the hot word is detected, we can write the average sound level to the environment variable, and that makes it accessible to all other parts of our code, such as our speech sensor or our voice sensor, and from there we can start listening and know when to stop listening. So now, when I uncomment this line and run both the client code and the brain on my Linux PC, you can see the average sound being constantly tracked. And when we trigger the hot word, the voice recording stops quickly after we stop talking. This will create a much more natural experience for our user when they're interacting with the artificial intelligence. It has been quite a while since the last video, as I've spent a bit of time setting up TensorFlow and testing a machine learning based chatbot. The processor on my old Linux PC was not compatible with the latest TensorFlow build, so I had to compile that from code on GitHub. But I found an excellent machine learning based chatbot on YouTube that not only generates responses to speech, it also caters for a level of randomness in the responses, and the really cool thing is, because it groups speech into categories, it effectively acts as an intent engine as well. The chatbot was developed by Tim from Tech with Tim, and although it uses some older functions in TensorFlow that are no longer available, an updated version of the code has been developed by Kunal Duran, who has a channel called Awareness M. You can see both of these examples in the video here and can search for them on YouTube. The downside of this solution is that you need to build up the corpus of statements and responses that the machine learning algorithm learns from. But this allows you to create a chatbot that is tuned for your particular use case. As you can see here from Kunal's GitHub repo, the corpus of possible statements and possible responses are stored in a JSON document. Currently in our listen function, after recording speech, we then send the recording to the Google API to turn our speech into text right here on the client device. And then we just repeat the text back. We can now use a machine learning model to determine the intent and reply with a suitable response. It seems to make sense to do both the speech-to-text and intent functions on the brain at the same time. I actually tried moving the speech-to-text operation to the brain, but it made it quite difficult to get the yes or no questioning working, which drives my speech paths. So I need to rethink how to structure this. For now, let's just send the transcribed text to the brain after we get it back from Google. I'm going to copy this code that sends a request to the brain and paste it into our listen function to send a new request type to fetch a suitable response to our transcribed text. The app ID will be voice, so I'll need logic in my brain_voice.py to handle it, and the action is getResponse with the transcribed text being sent along with it. Now let's test the process of triggering the hot word, recording some statement to be transcribed, which should then result in a message being sent to the brain for the voice logic with type getResponse. And you can see that has worked fine. We now need to ensure that we have the logic on our brain to handle that. Let's first take a look at the code used to build the machine learning model. Here is my own corpus of questions and responses, which is a bit limited right now, but I can expand it over time. The machine learning model works by matching the words found in any input statement to the words in our sample statements or patterns. Once a match is found, I can then either respond with one of the possible responses or reference a code that would kick off the chat path from my choose your own adventure type of chat model. If you think back to the architecture I was planning, this is exactly what I'd hoped for. In the code that builds the model, it allows for a total of 10,000 unique words when doing the modeling. If we Google the number of active words in the English language, we see that while there are about 170,000 words, only 20 to 30,000 are typically used. So let's up our maximum to 20,000, which should capture almost all of the words used in small talk. Also note that our model matches based on the existence of words, but not the order that they are spoken in. This should generally be okay for small statements. As you can see from listening to Yoda, if you reorganize the words in a statement, you usually still have the same intent. Although just be aware that there could be instances where this is not the case. At the bottom of the code is a small function to test the model. This logic gives an idea of how it can be incorporated into our AI brain logic. Once a match to a category is found, we can then look up our JSON file to check if a chat code exists, and then start a chat flow. Or otherwise, if there is no code, we return a suitable response from the category. Let's run the Python logic to build our model based on my updated JSON file, and then test it out. Note that input statements don't have to exactly match our pattern examples, as the model is returning a percentage estimate that a given statement matches a known pattern. We can actually set a cutoff percentage in our code to capture statements that have a low match to our categories. We can then write these to a log file and update our corpus with suitable responses and then rebuild our model. This will make our AI smarter over time. We can also set a suitable response for unknown statements like, "Sorry, I don't have a response for that." As you can see here, our AI matched an unknown response to the goodbye category, which is not very helpful. Given it has been quite a while between videos, I'm going to finish this one here and return when I've integrated the chatbot model into our AI code. If you want to be notified when I've completed that video, then please subscribe, and once again, thank you very much for watching.